Good afternoon, everyone. Welcome to our third episode of the Azure AppFest. Before we the topics of today, maybe let me share something up front. Basically, if you join our challenge to get certified on Azure, and then you update your LinkedIn profile with the Azure skill sets and certifications that you have conquered, you can participate to a lucky draw and basically get your chance to win a Surface device. And we have attached here a link that you can take, or later on when we will share this content, you will be able to click on this link and then join the challenge today. So let's go into the topic of today, and let's review a little bit also the calendar that brought us so far. Basically, we have already conducted a couple of episodes which were focused on the latest and greatest features of Azure PaaS and containers to develop applications. And then we had zoomed in our past session on DevSecOps and what are the tools that Azure provides to build secure applications. Today, we will talk about MLOps on Azure, which is a kind of extension of the DevSecOps process, which we talked about during the last session, but of course is more focused on machine learning operations, so basically DevOps for machine learning, with the aim of enabling data science and IT teams to collaborate basically and increase the pace of machine learning model development and deployment with all the connected considerations around monitoring, validation, and governance of the machine learning models. And then we will continue, just as an anticipation, on a couple of more sessions moving forward, which will be about boosting productivity with a set of tools that Visual Studio and GitHub, for example, from Microsoft, provide, as well as we will have other topics around hybrid transactional and analytical processing on Azure, and how to manage your security posture on Azure. I will reiterate again these next few sessions at the end of this one. Said this, let's move to the next slide. I would like to reemphasize a bit of the housekeeping rules for today. So first, this session is being recorded, and it will be available on demand afterwards. If you want to watch it again, we'll provide the link to do that. There is a Q&A panel in the interface that you have. So although we will be on mute, but basically you can ask any questions in that panel, and we will take some time during the conversation, as well as at the end of the presentation, for a Q&A session where we will elaborate on the questions that you ask. All right, so please do not share your video or audio in the interest of every attendee. Okay, let me introduce the speaker of today. So first of all, Charles Bernard is cloud solution architect and the Microsoft customer success team in Singapore. Charles has been working in the field of big data for close to 20 years now across Europe and Asia. And as part of that work, he has matured considerable experience in advanced analytics topics, which also include machine learning. And he will be introducing the topic of today, which is again, MLOps on Azure. And on the line, we also have New Ching. New Ching will help us moderate and answer, especially the questions that you may have during the course of the presentation. New Ching is part of the Global Black Belt organization of Microsoft, specializing on AI and ML. She has a Master of Computing Artificial Intelligence with NUS here in Singapore. And so we have lined up our experts to guide us through on this particular topic. I will be your moderator. I'm also part of the customer success team of Microsoft Singapore. And said this without further ado, Charles, please over to you for taking us through the content.
Thanks a lot, Andrea. Good afternoon, good morning, maybe everyone. So I'm Charles, and today's session, as Andrea said, it's about MLOps and how it is done on Azure. Okay. So first thing first, what's MLOps, right? We probably all of us, we have some idea, but let's get a line, on what's a definition of MLOps. So MLOps, it's basically, building, training a machine learning model and sending it to production. So it can be, to your serving layer, so it can be consumed by downstream applications, right? That's it, easy, right? It was a very short presentation. Thank you for joining. But no, actually, unfortunately, it's not that easy, right? That's only a very, very small step of your machine learning model development lifecycle, right? You have all this sequence of steps that you will need to go through. First, you need some data, right? Machine learning model, you need some data points to be able to train your model. So that will be the first step, right? You need to find a source, right? Which is relevant for your machine learning model and relevant for your business. What prediction, what outcome you want out of this machine learning model. Then you figure out, okay, I'm going to use this specific source or multiple sources. You need to do some analysis, exploratory, right? Is it the right data set? Do I have enough data points? Do I have all the features that, I was expecting to train my model? Yeah, okay, check the box. Now it's probably coming from different sources in different formats. You want to do a bit of standardization, cleansing, and so on, some what we also call feature engineering, on these different sources, right? That is done. Validation, so is it enough, right? Is it the quality that I'm expecting? Is it some data sets, some data points that I can trust? Yes, right? Now these training data sets, you need also a testing data set. So you will take this data set and split it into a training data set and testing data set, okay? So that's for the data preparation part only. Then come to, the interesting part. You want to train a model using this training data set. You will experiment different algorithm. You will use your favorite Python library or your R package, sorry. You will find the algorithm, coming from scikit-learn, TensorFlow, XGBoost, and so on, and start experimenting. That's called, building the model. Once you have done some experimentation, you get some good accuracy, you want to validate the model, right? This is the model that I'm going to set into production, to serve my customers, consumers, business, and so on. You might also want to add this extra step when you want to do some training at scale on large, huge data sets. So you need to have, some tools where you can send that and distribute the workload so it will train your model in parallel on terabytes, even petabytes of data. Once you're confident that's the best model, then you want to send it from your, dev environment to test, SIT, UAT, then prod, which is your serving layer that will be consumed by downstream application, end user, dashboard, and so on. And you don't want to send that and forget about it. You want to monitor it. You want to log everything. What's going on around your model, the performance of your model, the performance of the access. Through the API that you will use to consume this model, but also the accuracy. And why? Because also that this is a line. It's not a line. So monitoring logging is not the end, right? It's just going to feed back the first data ingestion again. So that's an infinite loop, right? That's your MLOps, okay? And the reason why you want to monitor and log in, because your model, the quality of your model will decline over time, right? That it's like that. There is nothing you can do about it. So you want to trigger all these steps all over again. So kind of complex, right? So MLOps is coming from this concept of Devops, which has been around, for many years now, and it's software engineering best practices. Okay, so you have these loops when you want to develop, do some code refactoring and deploy. It's also known as CI/CD, continuous integration, continuous delivery. MLOps will actually reuse this concept and apply that to your machine learning model development lifecycle. Although these concepts, and these steps have been invented, created, designed for software engineering, it will probably be more benefit for machine learning. The reason is that we have all experienced that, you have this, piece of software running in your organization that was, implemented, deployed way before you joined the company, and nobody knows about it. It's running, it's a black box, but it's doing the job, right? And the team of developers that moved on, left, there is no documentation, but it's just working, it's there out there, and you get good results. So you don't need to redeploy. It's not best practice, and you shouldn't do that, but that exists, right? We have all faced that before. That's not going to happen in machine learning. It's not going to happen, right? Your model, the quality of your model will decline over time. Because in machine learning, you have different, many factors that can impact the quality of your model. Your customer base can change, everything. You have so many factors that's not going to happen. So it's you want to apply this different concept. The first loop that you see, it's Devops, MLOps is Devops and beyond. You have this first loop where you're going to start experimenting, right? As I said, you need to do some data preparation, you need some business, domain expertise. This is how you provide some, great model if you really understand the business. Do some data preparation, I said before, exploratory, and so on. Then you want to apply because it's, getting closer and closer to software engineering, machine learning engineering. Then you want to do code refactoring, versioning. You want to keep different versions of your code. You want to use, a Git repo and so on. You want to do some unit testing, not only on the the scoring of your model, the outcome, but also the code quality. You want to do that. And that's the CI part, and CI/CD, the CD part that you want to operate that model. You want to send this model from your dev environment to your test, SIT, UAT, prod. You want to automate that. You want to code that, so it's it's automated, and you can trigger that every time you need to refresh, retrain your model. This is why you need some monitoring and triggering capabilities, to based on it's called data drifting. The quality will decrease, and you set your own threshold. And if you see the quality is going under this threshold, then you want to trigger that all over again to try to always get a good accuracy, because if a bad model could impact your business. In an e-commerce website, if you have a recommendation engine and the recommendation engine push me some products that I'm never going to buy, then it will impact the revenue. So you always want to have the best, running in production. All right. So it's complex. Fortunately, on Azure, you have all this suite of native services that you can deploy as PaaS, SaaS, platform as a service, software as a service, fully managed for you. In one click, you want to deploy that. It's scalable, it's cost efficient, and that will help you implement this complex pipeline, right? So on Azure, you have all your different sources, whether it's sitting on Azure, different cloud, on-prem, doesn't matter. You will deploy your Azure ML workspace, which will give you all the environment you need to get started, on your machine learning journey, right? You want to to have all the libraries, Python libraries, R packages in one place, maybe some notebook also, although that, on Azure, you can plug your IDE, VS Code. We'll see that I forgot to mention, but I've got a demo toward the end that I will, flash and showcase how it works on Azure. So you start experimenting, then you want to train your model. Also, you want to leverage, Azure Infra, which is highly scalable. And, you don't want to do that on your laptop. So you want to train your model, maybe on one VM or many VM, you want to distribute that. If it's an instance model, you want to have GPU, enabled VM also if you are in deep learning and you can benefit from GPU. Then when you're happy with your experiments and the best experiments become a model, you want to package all that, your model, but also all the dependencies, right? That you will package in one Docker image that you will register in your container registry that you will use later on to deploy that on Kubernetes, okay? On Azure, you have managed Kubernetes, AKS, but you could deploy that, it's using open standard, so there is no proprietary format here. You could deploy that anywhere, but you want to be able to package this as an artifact. And most important thing, you want to monitor, right? So monitor the quality of your model, as I said before, and if it's drifting, then you will integrate that within a CI/CD pipeline on Azure Devops. Again, I will flash how it looks like. Everything is fully integrated, seamlessly integrated. Then it will trigger the same pipeline again and send the new model, new version of your model with more features, less features, the new data set into production. Okay. So now that you have MLOps in place, you will get some benefits, right? We all do that, to get some benefits. One important benefit is about reproducibility and auditability. You want to code that. You don't want to do that manually. You don't want to have like manual validation. You can automate all of that because it's time to market. It's super important because, as I said, a bad model will impact, the business, the revenue, and you cannot let that happen. So you want to be able to reproduce that, okay, as a pipeline, and you want to be able to check the lineage, do troubleshooting, and so on, right? For auditability, and that's become very important. ML is taking, a lot of room within our different organizations, whatever the industry, but if it's even more true if you are in a highly regulated industry, I'm thinking FSI, the auditor will want at some point to, to check your model, right? So you need to keep all these artifacts and you need to tag them, the version, the date, the data set that was used, the features that were used, and so on, so they can be audited, right? You need to have that. Validation, packaging, part of MLOps, as I said, integrating, implementing, embracing the best software engineering, best practices for quality control, not only on the outcome of the model, but also the code, right? You want to unit test your code like you will do with any piece of software that you will develop. Comparison of the model, for the model quality, you want to keep that, you want to track that, you want later on, 6 months, 1 year down the line, you want to compare, model as it was last year with a model now or the week before, And also it's part of regulation, auditability. This is a subject that comes more and more, minimize the bias. So you want to show the regulator that your model, or even internally, you have some internal audit that you want to show it's not biased, right? On a specific feature, gender, location, and so on. And you want to be able to explain your model. You don't want that model, running somewhere, like the piece of software I was referring to earlier that nobody knows what's inside. You don't want to let that happen, right? It can be biased. All right. Automation, observability. So that's, I think, the essence, of MLOps, that you want to be able to control and CI/CD pipeline, control rollout capability. So you want to automate that and do it in a controlled way. You don't want, very often that we see that, some organization, some team, they train their model, whatever happen every week or every month. This is that they schedule that. No, you don't want to do that. You want to do it in a controlled way. You don't want to retrain a model if there is no need, right? Or you want to train a model as soon as possible, as soon as you detect that the quality is declining, right? Because it's cost involved, right? It's infra on the cloud, so you don't want to waste money and resources. Live comparison, so it's part also of this, data drifting, that you want to compare the prediction with the actual, reality and see if there is a gap, right? And always feedback. There is this feedback loop, to watch for drift. And if you detect drift, you set your own threshold, then it will trigger again this pipeline and improve the model, keep improving. All right, so I wanted to also to flash this reference architecture, Azure Machine Learning reference architecture on Azure and the different native services. So that would be the different steps that, if to start training, start developing your machine learning model on Azure, it will look like that, more or less. You have all your files, your sources that's coming from different sources, whatever format, you heard that before many times, structured, semi-structured, unstructured, it doesn't matter. You will store that in your data lake. And your data lake is powered by ADLS Gen 2, which is, the Azure native storage layer, blob storage that can scale very well, very cost efficient, and you want to leverage that. Synapse, so Synapse, it's not only a data warehouse, it comes with a very efficient SQL engine, but it's more than that. It's a one-stop analytics platform where you will get, of course, these data warehouse capabilities, but also, Spark. Spark, you will be able to deploy a Spark cluster, optimize Spark in a very distributed way, very performant way. That Spark is probably the best framework tool to do data cleansing, data ETL at scale, right? So you want to be able to use that. Then when you clean your data, you have your data set that you believe that's the right one. Then you want to plug your Azure Machine Learning and create your data set, tap into that and start training. As I said, find a trainer, find if you are using Python or R, find the library XGBoost, I don't know, that you are most familiar with, and start training, right? Something I always forgot to mention, authentication, authorization, secrets, keeping safe. Everything is integrated with Azure Active Directory, obviously, and Azure Key Vault. So this deployment is safe, okay? Once you've trained your model, your experiment, everything is tracked, then you want to register you don't want to register all experiment because some experiment will make no sense, provide poor quality, poor outcome. So you want to push the best and package it as, a Docker image with all the dependencies that you will push that into Azure Container Registry. So you will have all your images, different versions, the date, some metadata that you will use later on to deploy that into your serving layer. And it's a Docker image, so you want to deploy that on Kubernetes, at scale for inference at scale, and you can do that natively on Azure with AKS, which is the managed, Kubernetes services on Azure. So you don't need to make it easy, right? You don't want to manage this infra. You can let, Microsoft Azure manage that for you. So it will be deployed in a very scalable and, highly available way behind the load balancer. You will deploy your model as a REST endpoint that, you can, your downstream applications, end user can tap into that using a REST API, okay? And you want to keep monitoring, right? And if it goes down, then you want to retrain, okay? And for dashboarding, visualization, because you want to serve your business, you want to help the business, or even though you want to provide some dashboard to your customers, clients, you can do that, feedback the result, the prediction back into Synapse, maybe Synapse SQL, and plug Power BI. There is a native connector, very efficient connector, so you can build a live dashboard and reports. Okay, so on Azure MLOps capabilities, you have three pillars, right? Infrastructure as a code, three concepts, right? We'll show in the next slide what kind of options do you have to implement that, but you want to code that. You don't want to do it manually, right? You want to provide a code that, deploy your infrastructure as a code in dev, SIT, UAT, prod, and so on. You want to build this CI/CD pipeline, and be able to reuse that, to monitor that, to track that. And lastly, but probably the most important, you want to, to log, to track, to monitor the performance of your model. So on Azure, for infra as a code, you have some native, projects like Bicep, for domain-specific language, ARM, Azure Resource Manager template that you can use, reuse in a very code as infra way to deploy this resources, automate that. I didn't mention because I just wanted to focus on native services or, Microsoft kind of open source, even the project, but Terraform, obviously, if you use Terraform, there is no proprietary thing that, you wouldn't let you connect Terraform. Most of our customers use Terraform. It will work exactly the same. You can integrate with the different Azure, SDK, API. You have API, different languages, Azure ML SDK, so you can automate that using Python if you want to. You can use the Databricks REST API if you want to use Databricks for your ETL part, data preparation, or machine learning model training, and the Azure SDK, that you can use also to programmatically, manage your infra. Okay, for CI/CD pipeline, so you have this native tool, Azure Devops, where you're going to create your pipeline. So in a graphical way, using the UI, or you can code it, obviously, and get that from your repo. All the machine learning training services as part of Azure ML. DevOps for automated, you want to do unit testing using R and Python. You have libraries that you can install, or it's already there natively to do some unit tests. This is how you move from one environment to another and eventually push your model into production. It's fully integrated, within Azure DevOps. You have Azure Repo. GitHub is no part of the Microsoft family, but you could use also Bitbucket. And within Azure DevOps, so it's really a Swiss Army knife for this kind of development. You have Azure boards. You can think it as a Jira, where you have all your sprints. You can raise a ticket, in a very agile way. Okay, for performance monitoring, Azure ML as part of it, experiment tracking. So you don't want to have your spreadsheet like you run an experiment, not the accuracy, the time, the date, what trainer, what algorithm you used. Everything will be automatically logged for you, so you can review and later on audit, or for governance is also good to have. Monitoring also, all the app will be you can enable monitoring, so that will be done out of the box. Okay, so big picture of all the services that you will find and the native services. I'm only showing the first party or native service. Obviously, we have many partners and ISV that you can use on Azure, but the native services, for data processing, Azure Databricks. So Databricks is a different company, obviously, but only on Azure, it's a first-party service. That means you don't need to go to the marketplace. It's already there in your portal. You just click and you can deploy a Databricks workspace, and it's fully integrated with the rest of the stack. Machine learning workspace, you can build a pipeline there also to process, do some data preparation. Synapse, as I said, with Spark in Synapse, you can do ETL at scale. That's the processing layer. For storage, you want to leverage Data Lake on Azure, powered by ADLS Gen 2, where you're going to store any files in any format, images also if you have this specific deep learning use case. Synapse Analytics also, it's also data warehouse. So if you have a relational, data sets that you need to access, in very low latency, you can store that in a very relational way on Azure Synapse. For model training, Synapse, again, with Spark ML, you can, the ML library in Spark, you can train that in a very distributed way. On Azure Machine Learning with Python, you can do your training as well. You can use Azure Databricks, obviously. You have all this workspace to train your machine learning model. And you have VMs, so you will leverage, of course, the Azure infra, and you can deploy VMs. If you want more flexibility, install anything you want on your VM, okay? Once you've done your training, you push that to container registry, okay? And for testing and deployment in production at scale, you would use AKS. Back then, you would, put the feedback, the prediction, the scoring, inference result into Synapse, if you want to plug a dashboard, or directly, as I said, you can connect your downstream dashboard user directly to AKS through a REST endpoint. For orchestration, everything is fully integrated natively with Data Factory, so you can orchestrate all this data preparation and so on. For identity, authorization, authentication, keeping all your secrets, password as your Active Directory Key Vault. For monitoring, App Insight and Monitor. And also we have this cross, categories, tools that you can use across the board. And Azure DevOps, obviously, to manage all of that. Okay, so now I'm going to jump into the demo. I'm not going to run any code because, as you will see, it takes too much time, right? We have only 20 minutes left or even less. So I'm just going to go through the code, but I'm not going to run the code. So I was wondering what kind of demo, you wanted to see. So I made a guess. I found that, it's always so probably some of you are already really advanced and you have the CI/CD pipeline, already running and pushing some of it in production. Some of you are getting started only, or you plan to start that in the next month. And how do you get started? So I wanted to focus on how do you get started, because the first step is probably the most complex one, right? Where do I start? Okay, so I wanted to show a repo. So let me, okay. I wanted to show this repo, which is publicly available. That's created by some of my colleagues, in the machine learning space, some, experts in SMEs, data scientists, that they created this MLOps solution accelerator, which is really great. I came across that, and it gives you a framework template, code boilerplate, that you can use, to get started, right? Because it's always the first step is the most difficult on Azure. So it's using all the Azure native services. All right, so you can clone this, and you should do that, and it will give you all the techniques, and the concepts you need to move from your notebook that, you can implement on your laptop using Jupyter or any notebook, or even IDE. So it's fully integrated with Visual Studio. There is a native integration, you can develop using this IDE VS Code, on your laptop and push that onto Azure ML Workspace. And, you want to automate. So you want to have this DevOps pipeline using this notebook as a Python script, and send that, do some deployed infra, create this artifact packaging, and deploy that in different environments, dev, SAT, UAT, prod. Okay, so in DevOps, the way you will start in DevOps, so you will go to DevOps, you will create a new project, and you can clone this. Okay, you can clone it anywhere, right? It's on GitHub. You can clone this repo anywhere. All right, so you will clone that onto your, repos or GitHub or Bitbucket, and you will create a master branch, and then it will, clone the project, the template, with everything to boilerplate, everything to get you started, right? And so if I come down, so it will implement the core MLOps principle. I'm not going to go through that again, and it will, let me maybe increase, it might be a bit small. Maybe it's all right. Okay, so it will give you, this, this structure, to get you started, right? Where you have your Azure pipelines, for CI/CD, some documentation. It's important, to document what you are doing, because, you will work as a team, or some different team will actually, take this project and package it and move it to production. So you want to document everything, and, you already have some documentation, your notebooks, some scripts that already exist, to do unit testing and so on, and the source code, right? So to get started, so as I said, you will create a dev branch. Okay, and this is how you should get started. So if you go to doc, this is something I wanted to show, because this is always a question I get. What about the branching strategy? Okay, how do you apply, how do you apply these DevOps techniques, right? When you are a data scientist, sometimes you are not super familiar, with this concept. So it will give you, some documentation to get started. So the minimum, you will have a dev branch and a master branch. That would be the, the dev environment and the prod, right? This is why in the configuration, you will find two different config files, one for your dev environment and one for your prod environment, right? And let me open that in parallel in Visual Studio, so I can keep both. I just clone that in VS Studio, and you can see that I will be able, I mean, I'm not going to run any code, but I can connect directly to my Azure ML workspace. So everything is fully integrated. And I do understand that notebooks, it's good for some exploratory, when you get started, when you're learning, but or you want to experiment something quickly, but as big project, complex project, you want to use some ID. So with VS, can download that, and it's fully integrated. All right, so what I wanted to show is the configuration. So it's very simple, for dev, you would have one set of key value, for your dev environment. You can create your resource group. That's some, Azure concept, provide the name, location where you want to deploy that, and so on. You will have one for prod. So it's just to get you started, right? You will have more environments, so you can duplicate that, have SIT, UIT, and finally prod. But or more than that, or less than that, at least probably two, to get started. And you can reuse that. You can, once you clone the project, you can modify it the way you want, and it's within your repo. Okay. So now I just want to go to the pipeline section. All right. So you will have 3 pipelines that's already created for you that you can modify according to your needs. All right. So the first one is to set up the infra. So it's probably going to be a different team. You are part of the data scientist team, so probably not going to touch this pipeline, not execute it. It might be your infra team, but you will need to deploy the infra on Azure to build this CI/CD pipeline. So I'm not going to go in detail, but it's a YAML file, and you have a trigger because you want to trigger this pipeline. So trigger is set to none, but actually it will trigger only if we come back to the branching strategy. Okay, let's go there maybe again. So in dev, you have your dev branch, and if you want to create a new feature or fix a bug, then you will create your own branch, and you will do a pull request to the dev branch. And every time there is a pull request, it will trigger this pipeline. Okay, and you can do a pull request from dev to main, and it will trigger the same pipeline, but with a different, configuration file. And there is 2, but there is only one. Prod, test prod could be SIT, UIT, and this is how it works, right? So quite this concept will be very familiar for software engineers, developer. Okay, so if I go back to my pipeline, it's just listing, describing the steps. So you see that's pointing to the different configuration files that I was showing a minute ago, and it will deploy the infra in dev and in prod. So if you do a pull request to the dev branch, it will only execute the dev part. Okay, and it will create a compute system. So it will, in the template, it will create Azure your resource group, Azure ML workspace, all the dependencies you need. So Kubernetes cluster, a key vault, storage account, and so on. Within then, it will go into the Azure ML workspace, create a compute target that you need to train the model. That's the minimum you need. And that's an extra step, but that can be done also by the data engineering team, do some data preparation. So they can already, get a source for you and register a data set, a data store, a data set that you will use, to train your machine learning model. So once you get triggered, it will run in DevOps, so it will deploy an agent. Okay, so I ran that a few weeks ago, and it takes 24 minutes. This is why I cannot do it live, but that's very graphical way to see your CI/CD pipeline. So it's only in dev right now, and you can see it. So you have this lineage, which is very good to have, to monitor, to troubleshoot, to debug. Just going to run that. So prod, nesting in prod. So you can see that the different steps that were got executed, right? And I can zoom in, right? So it will be deployed on a Azure Devops agent, so running, within a Windows machine or a Linux machine using Ubuntu, for example, and run all these steps, right? We've seen that. So deploy the infra, create a workspace, create a compute target for batch inference, for live inference, do some data preparation. And if I click on that, you will see all the logs, right? So what it did, for example, you see in that part, when you deploy your workspace environment, you want to specify which version of Python you want to use, which are the dependencies, the libraries, the packages that you want to install directly within your workspace. So you can automate that, obviously. All right. And once it's done, when you're going to log in into your workspace, it will create all you need, the infra you need. So it will create, you can change the name, obviously, that's the naming convention that comes with the template, but you can change everything. So it will create this resource group in dev, so you can have a different naming convention, obviously, and create what you need. So the storage account, as you know, you've seen that the reference architecture earlier, this key vault to keep all your secret, this container registry for all your Docker image, the Azure ML workspace, for machine learning, AKS, to deploy the model at scale within a REST endpoint, and some monitoring tool, okay, to monitor the application. Okay, so once Azure ML is up and running, you can open it to it will be open to your data scientist, and you can use your ID. You don't need to log in if you want to use your ID. It's perfect. And you will have, sorry, that's not the one, so that's here. You will have all this, so that will be your workspace for all your machine learning, workloads, developments, and testing, and so on. And it will create that for you. Okay, so you just need to come in. You see that there is already a compute created for you, compute cluster, for testing. You will have, if your infra team or data engineering team is kind enough, they will, create a data store for you and maybe a data set. So there is a dummy data set right now, but it's just to show that, data set is version, you have some metadata. That's my data sets coming from blob storage, for example. And, you have all the metadata. So you can explore, you have some exploratory analysis capability. So it's a dummy data set. And what the template is trying to do is just column 1 and column 2 will be my features, and I will predict column 3. But you will use your own data sets just to get you started. So it's easier, you understand, where you have to implement things, right? Okay, it's also give you a code snippet that you can use, reuse to get started. So this is how, for example, you will load this data set from the storage account. So the data set from, so storage account, that would be the data store. Data store could be Synapse, Cosmos DB, could be anything, right? And you will load that as a pandas, data frame, or Spark data frame if you want to use that, and then you can start experimenting. And that will be the second pipeline. So you have everything in place, right? You need to get starting with your ML stuff, ML workload. All right, so if I go back to DevOps, and that will be the second pipeline. All right, this one, the ML pipeline. Again, I can flash the code, so you will have these different steps. So it looks like that on in the code. So you have the second pipeline for modeling. All right, again, steps. So you have 2 branches. You will have many branches, in a real world scenario. And every time there is a pull request, you take your model, you retrain your model, and you will commit, or you change, you change the code, you use a different algorithm and so on, you tune, hyperparameter, you tune that, and you do a pull request to trigger this entire pipeline again. So retrain the model and redeploy the model. So it will get the code, all the dependency, could be updating the training data set. So if you want to reuse something that is already there, or, do all this data preparation again, connecting to the source, getting the data, do the cleansing, feature engineering, and so on, and then run the training. So you will point to your Python script that's used for training. You have different templates, Python script, and it will run that. So I think we have some example here. There is a Python script to train, one to score, one to register. Okay, you have everything, so you can get started. That you could use that as a base, to implement your own CI/CD pipeline. And in that specific scenario here, your machine learning training and deploying pipeline. Okay, so you would train that, register the model in container registry, and then deploy that in ACI. So it's Azure Container Instance, like Kubernetes, but it's more for as well as Kubernetes. So it's good for testing. And then when you're happy with the test, unit test, then yeah, good to go. And you can have validation against the steps. So you can send an email to some team. They will you need to validate, for this pipeline to move from the step to the other step, and someone can, validate, okay, the result of the unit test is good. Okay, let's move on to the next step, and that will be sent to AKS, for serving. Okay, So if I go back to Azure DevOps, I can see all the different steps, get all the code, Python, dependency, library, and so on, and go through these different steps, get a new data set, refresh the data set, train the model, package the model as an artifact, and then send that to ACI test the web service. If it's good, move on to the next step on AKS. Okay. And that will use Azure ML under the hood. So if I go back to Azure ML, you can see that I've got some experiment, and that will be one of the experiments. So last run that was, triggered by the pipeline. So you have some metrics, you have some metadata, you have, that's obviously a fake model because the accuracy is very good, approach to 100%, but this is how you will, compare all your model, and accuracy, you push the best one into production, right? You have some logs, so, it's not a black box, you have everything. And what I wanted to show, you have also a way to check, take the pipeline from here as well. So for example, you can see the pipeline. Okay, here. So for example, for regulation, you can show the regulator, okay, this experiment, this model is actually tracing back, linking back to this experiment. So you have the version, the date, which data set has been used, my data set, which storage account, which version, each data set is version. So you can show the regulator, okay, that's my data set. This is how I prepare the data, and you have some logs, test, training data set, where it's coming from. If there is some error, also it's very good for troubleshooting. Train the model. Okay, it was using this algorithm at that time, then evaluate the model and register the model. Okay, so everything in the code, I don't do anything extra. It's just, using the native, Azure ML API, and it will track everything for you out of the box. Okay, I'm just checking the time. All right, so, and at the end, you will have the model, running. So you have this web service, it's running on AKS. Okay, so this provides you a REST endpoint that you can share, and they will need the token, you have different ways to authenticate your downstream application. We need the token to actually consume from this REST endpoint. So that's your model, calling this model, and you have some also code snippet to, example to actually, in C#, Python, R, to actually consume this model. Okay, and that will be a load balancer, so you can have many consumers, and it will load balance, the load. Okay, so it's highly scalable. All right, just look if I'm not missing anything, compute environment, and so on. Okay, so there is also another pipeline that is here as an example, but probably, you have different way to serve a model. So that could be, streaming. So if you have a stream, probably you will use Spark, and you will use your model as a Spark function to, when you stream your data point through your streaming pipeline, that you can do scoring. For real-time kind of ad hoc live, you will use that Kubernetes that as shown, and the web service, right? For real-time live ad hoc scoring. And sometimes you have also some what we call batch inference, batch scoring, where you have like every day or every week, you have a huge volume of data points in a database or on, on file, on your storage account that you want to score. You want to do some inference. You can also automate this. So this pipeline is really simple, but it's just to show that it will, again, run some unit tests, maybe, every day, or if you run that once a week, get a new data set coming from the source for the past week, and run this scoring in a batch mode, okay? And probably store the result back into some Synapse table, why not? Or back to your storage account, and you can plug, if you Synapse, you can plug your Power BI dashboard and see the result. Okay. So that's it for me. I think I'm on time. We want to open the floor now to Q&A. Let me go back to the slides. Slideshow. And...
Thanks, Charles.
All right. So yeah, Q&A. Thank you.
Let us visualize also the concept through a demo, a live demo. So Okay, maybe let me start from a question that was asked just now. Do you recommend? I mean, the question is there any checklist to get started on MLOps? So I guess we could interpret this as is there is there a way that you recommend for somebody starting a new?
Yeah, so I'm pretty sure if you ask different teams, they would have their own checklist, but I think this one is quite comprehensive and easy to follow. So yeah, that would be my recommendation. But it's just to get started, and as you will become more mature, you will change some stuff. But to get started, yeah, I think it's a good way to get started. You have the basic checklist.
Okay, there was a question which we answered, but let me walk you through, maybe Chelsea, if there are whether we have answered comprehensively. If not, you can maybe help to elaborate. But there was a question related to, so the question was, can MLflow be used with Azure MLOps? So it was kind of related to possible ways of managing both, right?
So MLflow, yeah, MLflow is an open source project coming from Databricks. There is some integration with Azure ML, so you can install MLflow is just a library. So it works, yeah, it's fully integrated. We have some documentation that can be used if you like MLflow and you are more familiar with MLflow. It can be used. It will be a bit redundant and probably not as good as on Databricks, it's fully integrated. That's the way they do MLOps. On Azure ML, we have our own, library, but MLflow can be integrated. Yeah, there is no technical limitation.
Thanks, Charles. And let us give maybe a couple of more minutes to see whether there are any more questions from the audience. There were a few while you were presenting.
Okay, I couldn't see them, but
which we answered. Yeah, which we have answered related to how to do code versioning, especially in case of model reuse. And then we were suggesting to basically register the model. It's like checking in codes, and then later on you were also going through that part during your demo.
Yeah, but it's actually a good point. This is something, let me go back. So yeah, so your model, also the image. So if I go back to this and I open this container registry, you will see that we will version the model, but also the image. So we have two repositories, and you see that your model. So there was one version, and that will be the latest. So that will point to the Docker image with your model and all the dependencies. Yeah, good point. I forgot to show that.
Thanks. Let me see. Okay, we also answered another one, which was related to the difference between data stores and data sets. I think we clarified this in the live Q&A. Basically, think of data stores like the database and the data sets like the database tables. So the engines that store your data sources basically, and then the actual data that is stored within a data source.
Yep, exactly. So your data store will point to a source system. For example, so in that demo, it's a blob storage account, and then you can create a data store. So a data store can be a set of files, a table, specific table, for taxi fare, credit scoring, and so on. But when you register a data store, after that you can create a data set. That's a view of some of your files or tables on your data store.
Okay.
So you can see this data set is pointing to this data store. Yep.
Okay, that's a question that came in right now, and Okay, some of the other pipeline features like viewing stages aren't visible in our instances. Is there any configuration that we need to update? I guess that this could be related to your particular environment. So maybe whoever has asked this question, please contact us afterwards, and we can have somebody from Microsoft working with you on this. If you have access to support, you can also raise a support request, and Microsoft will get in touch with you. Okay, there's an interesting question, maybe architecturally speaking. The question is whether what is the recommended approach? Whether it would be Databricks plus MLflow plus Azure ML, or Azure ML alone, or Databricks alone. So multiple options, multiple choices. How would you go about recommending one versus the other?
Yeah, that's a good question. Let me. Okay, I wanted to. Sorry. Okay, so yeah, so that's true. There is a bit of overlap, especially between Databricks and Synapse, and there is less and less gap, right? So for a training model at scale, or for ETL, at scale, when I say ETL, I should say data preparation. Spark is probably the best tool, right? On machine learning, on Azure machine learning, you can use vanilla Python, but you wouldn't be able to parallelize. Although that now you have this compute target, so you could send that to Databricks from machine learning. There is a connector, so but it will run anyway. If you want to do the training, in a distributed mode, then it will push that to Synapse or Databricks. So probably, Synapse, it's not the SQL engine part, but the Spark, engine is more recent than Databricks. So Databricks, the Spark probably engine is more mature right now. So that's, if you use Spark, but if you distribute your training, right? Because most of the time, your training data set is not as large as you need to get benefits from Spark. And some algorithm, the Spark ML library, you have different algorithms, but you don't have all algorithms out there because they cannot all be parallelized. Okay, so Azure ML that you've seen that you have this workspace platform to do your ML training, testing, experimentation. You could do that also on Databricks. It's really feeling right. If you they look the same but a bit different in some way. So it's really how do you feel? Do you prefer the Databricks notebook or the Azure machine learning notebook? It's really up to you. You have the choice. You have the choice. But yeah, there is a bit of overlap. And so that was for the question between Databricks, Synapse, and there was.
There was basically, yeah, Databricks plus MLflow and AML. So or the three together, or Databricks alone, or AML alone.
It can be a combination, so it can be alone, combination. You have options.
Thanks for elaborating on that one. I think that was interesting, and it always also depends, I guess, on the scenarios that you're actually facing time to time, depending on the use cases, the amount of data that you have to process, and so on. You will
the volume. Yep.
Yeah, a number of considerations. I guess the important thing, in fact, is that you have choices and options that you can combine in ways that work for a given scenario at hand, rather than giving a fixed approach, basically. And maybe the time is almost up, so I would maybe I see that questions are still keep coming. So what I would recommend is for those of you for which we have not answered question, get in touch with us. You will have our contacts and links after the presentation. We will be more than happy, to be in touch with you and answer your particular questions in the context of your own projects. For today, we have to wrap up, and so basically, yeah, if we on this slide over here, the first thing is that we would love to hear your feedback on the session, and there's a QR code here, and please, if you can, let us know whether how relevant this was for you, because we can the topics especially that we talk about, because then we can organize more of these events that are tuned according to the needs that you have. So feedback, the QR code is here. And then just a reminder of a few upcoming sessions again. So we have the next one next week is a boost your productivity with Visual Studio and GitHub Tools. And then the following 2 weeks, we have hybrid transactional and analytical processing on Azure. So how you bridge the gap between operational databases and analytics type of solution in a seamless way. As well as last week of March, a very important session on how to manage your security posture on Azure, and in particular using Microsoft Sentinel. And I think with this, I thank you everyone in the audience, and thanks Charles, and thanks Niu-Ching for
thank you everyone
getting us. Thank you.
Thank you.